Hi there, so I am going to assume right now that you are absolutely sorted and very comfortable with approximating the binomial by the normal and also using a continuity correction. If you are, then this is going to be a walk in the park. If you're not, not quite a nice walk, and I suggest you actually get to grips with those two things before making a start on this. So, our example. In February, I don't know if you know this, but Qatar's average daily temperature is 23 degrees Celsius. So I want to know how likely is it that the temperature on the first Monday in February will exceed 25 degrees Celsius, so a warmer than average day. So remember our Poisson distribution. Let's use a nice blue for Qatar's blue waters. That our lambda is our average, our mean, our rate. So in this case, it is 23 degrees Celsius. And in our tables, our Poisson distribution tables, the ones you get given, these only go up to 10, not 23. So it might work for February in the UK, but it is probably about 5 degrees. That will work fine with that. But in Qatar, it's a little bit warmer, but a bit sunnier. Doesn't quite fit nicely onto our tables. So we need to approximate using a normal distribution. And the really nice thing here is, under the normal, when we approximate it, our mean is 23. And equally, our variance is also 23. Remember in Poisson, that lambda is the mean as well as being the variance. So the first thing we need to do is look at our probability. So we want to find the temperature that exceeds 25. So if I take probability that x is bigger than 25 on a number line, so 24, 25, 26, 27, bigger than 25, not including it, so we're looking at 26 upwards, which means with a slight continuity correction, when it's continuous, 25.5 upwards is what we want. So probability that y is bigger than or equal to 25.5, with that continuity correction just slipped in there. So for our normal distribution, anybody want to use the normal tables where the distribution is 0, 1. So you're going to convert it, remembering that formula. So it's 25.5 is our x, take away the mean of 23, over the standard deviation, that's the variance, so you want the square root of 23, which is a probability that z is bigger than 0.5213. And like with any good normal distribution, we're going to sketch ourselves a little graph to see what's going on. We want bigger than 0. In our table is about 0.52. Okay, so we have 0.52 in our tables. So we need to do, to find this area, one, take away the probability that z is less than 0.52, which is, if you look in your books, 1 minus 0.6985, which is 0.3015, which which means there is a 30% chance that the first mundane kata will exceed 25 degrees Celsius. And that's essentially it. So all you need to really remember is that for the Poisson, the lambda is the mean and it's the variance. So you could write this as root 23 squared if you preferred. And then it's exactly the same as before. Don't forget the correction. Common mistake is to forget the correction, and make sure you always draw yourself a little diagram. Even if it looks easy, just get the habit of doing that so you don't sort of make any little silly mistakes.